It's not like a floating bearing. So the platter actually has some grounding, so you know where the axis of this rotation is. You then allow the platter and the vinyl to stay in a controlled relationship with where the arm is mounted. And then obviously the function of the arm is to support the cartridge but accommodate the record within the audio band. So it makes sure that the cartridge does its job. So there are functions that the tone arm has to do, there are functions that the record player has to do, and there are functions that the motor drive has to do.
สวัสดีครับวันนี้ก็ทางทีมงาน Audiophile นะครับก็ได้มีโอกาสได้มาเยือนร้านไฮเอ Audio นะครับแล้วก็วันนี้เรามีโอกาสที่ทางผู้บริหารแล้วก็เจ้าของบริษัท Turntable ของอังกฤษครับVertere Turntable นะครับก็ได้มาแวะเวียนผ่านมาที่ประเทศไทยนะครับเป็นโอกาสที่เราจะได้พูดคุยกับทางมิสเตอร์โทรัสนะครับแล้วก็โปรดักต์ของ Vertere นะครับในครั้งนี้ก็จะมีมิสเตอร์โทรัสนะครับas our guest แล้วก็มีเพื่อนผมอีกคนนึงครับคุณพงศธรนะครับที่จะร่วมพูดคุยด้วยนะครับครับ First question is what is the philosophy of Vertere Turntable of Vertere product?
Good morning. The original idea for the Vertere part of my audio life has been to try to understand the best ways to get what they originally put on the vinyl. And we have been fortunate, I would say, that we have relationship with certain members of the industry in recording, mastering, cutting, that has given us the ability to have a correct reference point between what is the source and what is coming from the record that we're picking up, if you may say, to try to get the closest I can to what is actually on the source material. And this led to the birth of the HB cables that allowed us to make sure that we get the harmonic structure of the music, and then led to the reference tone arm. That was the next product. And then from the reference tone arm, I built the RG1 record player, and then the reference tone arm RG1 became effectively the mother or the father of the rest. So the SG1, SG tone arm, the MG with the SG tone arm, and the DG after that. And the same way with the motor drives. It's the one active component in the system. And the record player is basically a passive product. The only item that puts energy into the system, and that energy then translates through the diamond cantilever of the cartridge to become your music, actually comes from the motor. So the drive system is part of the heart of the record player, that most of the mechanical isolation, if you want to call, it's not actually isolation from external induced movements. It's designed to deal with the internally induced movements. So the concept and the philosophy behind this, in order to allow the cartridge to extract the information correctly from the groove, is to ensure the relationship between the vinyl and the stylus is controlled, the drive is controlled, and also because of these movements, any internally induced movement is put in directions where it does not affect what you're extracting from the record, to get as close as possible to the source material. And that is our only reference point. We only compare any of the record players, whether it's a DG, MG, SG, RG, we always compare it to what was the source material that was put on the record, trying to get close to this, but in the same way, in the same direction. And that is the gist of Vertere.
According to manage the vibration, both internal and external, you choose to multi-print design and rubber suspension. Why you choose this? Other brand of English turntable maybe use spring or maybe the solid turntable, but why you choose?
I did use springs long time ago, but not on a turntable. I use it on our CD transport. When you're dealing with vinyl, you are running the record at constant angular speed. And when you allow a degree of freedom for example, the movement in the plinth, for example, this degree of freedom is not unique to one part. For example, if you have a very soft sprung suspension, because if you make the springs very big and very thick and very heavy, then the springs become a conductor of noise. So you defeat the object. So in order to have a sprung suspension, you need relatively light structure so that the springs are much smaller. So they're not actually becoming a big conductor themselves. When you do that, if the structure can move in a certain direction, so can the platter move relative to that structure. You introduce a almost like a frequency flow reference point. So for example, if you have a say 4 or 5 hertz suspension, the structure doesn't know below 4 or 5 hertz. It can be anything. So your frequency response begins to get obscured at the bottom end. It doesn't go to DC effectively. What we do here is that the structure that you have at this position, it helps with external, but it's more working with the motor and the belt. And the motor itself has got a degree of freedom around its own axis, which means any movement in the system, the body of the motor will react first because it's a lighter structure and it has basically a very low frequency compliance due to the electromagnetic field and the silicon restraint that we put on there. So your frequency response begins to go down almost below 1 hertz rather than being about 4 or 5 hertz. Now if you go absolutely solid, then you need so much mass in order to deal with this that the mass starts storing the energy. It's a little bit like yin and yang. You need some hardness but some softness in order to deal with both sides of the equation rather than only with one side of the equation. And that's why I chose the geometry that you see on the record player, and also the way the motor interacts with the belt, the way the belt interacts with the platter, and the same way that the sub plinth interacts with the rest of the plinth and with the motor. So they're trying to keep the relationship between the cartridge body and the vinyl in the same plane. So they move together and they don't do this kind of movement.
And also the motor, you have the suspension also.
It's not a suspension as such. It's got a degree of freedom around its own axis. We have two precision bearings on the bottom. On the SG, the motor itself is actually supported in what we call the tulip. It's got 6 contact points that we can align the motor relative to the axis of the tulip. And then the whole tulip with the contact points tries to direct the noise that it is generated in the body of the motor into the tulip, back into the structure, which is actually this, what we call the top plinth. And the top plinth is ground because it's effectively directly coupled to the support structure that the record player sits on. And the reason why the motor can rotate about its own axis, if you imagine you want to keep a constant speed on the platter, for example, the inertia of the platter is what defines the micro movement of the speed. So within a very small angular distance, what keeps the speed constant is really the inertia of the platter, not the power of the motor. Because motor does not rotate, it jumps between the poles. The belt is compliant. It does 3 things. One is that it ensures that the limited amount of vibration can go through it to the platter. But also, because it's compliant, it can move with the tension slightly. So the tension can go up and can go down. But you want to minimize this. The motor we use is a synchronous motor. And this wants to run at one frequency only, which is the frequency that the motor drive gives it. It doesn't want to slow down. It doesn't want to speed up. If you try to slow down a synchronous motor, it will stall. But with a synchronous motor, it wants to stay in synchronicity, stay at that particular speed. Now, at any point in time, there is a difference between the speed of the motor and the speed of the platter. Sometimes they coincide and they will be exactly the same, but most of the time they're slightly out from each other. Now, in order to keep the platter dictating, we allow the motor to adjust its body position to make sure that the tension in the belt is constant. If, for example, you look at when I said about the belt being slightly elastic, if you imagine that you make the belt absolutely rigid, so it's like a string, for example, because you have a differential always between the speed of the motor and the speed of the platter, that string is either loose or is tight. It's loose, it's tight. And so with having the belt of a certain material, ground to precision, having the motor running synchronous with a motor drive that controls the motor properly, ensuring that the bearing on the platter that allows the platter to rotate has minimal friction and stiction, and at the same time it references everything, so it's not like a floating bearing. So the platter actually has some grounding, so you know where the axis of this rotation is. You then allow the platter and the vinyl to stay in a controlled relationship with where the arm is mounted. And then obviously the function of the arm is to support the cartridge but accommodate the record within the audio band. So it makes sure that the cartridge does its job. So there are functions that the tone arm has to do, there are functions that the record player has to do, and there are functions that the motor drive has to do.
So, according to the top model, which is pre-print design, how could we differentiate between the SG and RG model?
The SG and the RG share exactly the same structure. RG was the first record player that was made, and the platter assembly is two pieces. There's a bottom part and the top part. I've actually got I've brought those platters. If you want to see, I can show you. And each part is a tuning fork at a different frequency. And when they're put together, one wants to vibrate at one frequency, the other at the other frequency, so they actually stop each other making any resonances. This is pure friction, so it's linear. Your damping is resistive. It's working only on friction between the two parts. And because of the nature of this, the weight of the platter became, from memory, it was something like 4.7 kilos or something like this. And I used a tungsten carbide spindle, which in terms of circularity, straightness, roundness, and concentricity is well within 1 micron. Very accurate, and we did the bearing housing very accurate, and we used the silicon nitride for the ball, etc. But all of this added an enormous amount of cost to the manufacturing. So although the platter was two pieces, it actually cost nearly 3.5 times a one-piece platter, because it's difficult to machine. That it has a shape on the inside to match the shape of the other one. So my thinking was, how can I get the best out of this, but at a lower manufacturing cost? So rather than compromising on the structure and the way the motor is done, I compromised on the way the platter was made. And so the platter became one piece. That meant that we could go to the hardened stainless spindle and then use a tungsten carbide ball. So the bearing spindle, the ball, and the platter are the main different components in the system, but they constitute a relatively large proportion of the manufacturing.
One of the unique design of your turntable is the spindle sleeve.
The spindle cap. Yes. Yes.
Please explain how you find this. And well, I think it's really work.
Yeah, this is going back nearly 40 years. When I was designing the Xerxes, that was why the idea came with having a fibrous support like a mat. So it's effectively a cushion of air underneath the vinyl. And when it came to the spindle, I was thinking, well, every time you put the record on, it doesn't matter how carefully you put it, at one point it will be contacting the spindle. And this means that you're directly coupling the vinyl to the rest of the structure rather than actually sitting on that cushion of air. And then I thought, well, why don't we make a spindle cap so you position the spindle cap, put the record on, then you can take it off. And once you take it off, then the record's contact is only the mat, the fibrous mat, which is effectively air.
Yes.
And that's how it came about.
As I test, is really improve the sound with spindle cap.
It's effectively lowering your noise floor. Even with the best bearings in the world, even with the best machining and everything that you do, there are still vibrations and noises in the structure. And the further away you can get it from the vinyl, the better, effectively.
So I, follow your design quite a while, for decades, let's say. So I see your design always come up with one motor and one tone arm.
Yes.
Don't you want to do a fancy stuff like servo motors, 2 tone arms?
Let's take the motor first.
Right.
As I said, this is a passive design. And the only active component is the motor. It's not unlike a car. It's not unlike a loudspeaker, for example. Although the motor is the one source of energy, and that is where you get your music from, it also happens to be the one source of disturbance. In some designs, you may want to have multiple motors, for example, or multiple pulleys and things. Generally, these designs have a problem that they are trying to solve. For example, if you have an inverted bearing system, so the platter is actually supported with a spindle up and the bearing housing down, for example.
Right.
That way, your contact point is close to the center of gravity. And when the contact point is close to the center of gravity, statically, the platter is stable. But as soon as the platter starts rotating, it becomes a gyroscope.
Right.
And at center of gravity, the gyroscope is totally unstable. So it can do anything it wants. Now, if you have one motor trying to drive it, then the platter is still doing this. But now maybe if you put 2 or 3 or 4 contacts, you're trying to stabilize it. Yeah? But this, for me, I would just turn the bearing the other way. Then I don't have this problem. So I don't need more motors or I don't need more pulleys. Yeah? So the idea of having more than one source of energy, for me, it just creates more problems to solve. Then say you have one, why do you have one tone arm?
Right.
Once you make a decision as to where the drive is, so the energy, input of energy, say, is in this location. My bearing is in this location. The belts, tensions acting in these directions. In order to work with the motor and the belt to allow the platter to dictate the rotational speed relative to a structure, in this case what we call the subplinth.
Right.
Then because of all these geometrical positional that you have and the directions of pull and push and rotation, you will have an optimum position for mounting the tone arm. If you need more than one tone arm, to get the best, I would say get 2 turntables.
Right.
If you're designing a Formula One car, once you identify where the engine is, where the gearbox is, where the clutch is, where the brakes are, where the suspension is, you can't have like 3 positions for the driver.
Right.
There's only one position that suits
Right.
this structure. You want to have another position, design another car. Somebody says, well, if I put 2 cartridges identical, 2 tone arms identical, I always prefer this one than to that one. So that's why I thought, okay, one position for the tone arm, one position for the motor. And
It's about the optimum
yeah,
design.
optimum, yeah,
Right. I can see
optimizing,
that.
yes.
And all the part of your turntable is made in-house or you outsource?
We don't do any raw manufacturing because some of the components, they require very specialized machinery to use. And not just the machinery, but also the personnel to operate it. So we utilize whoever we think is the best. I mean, I work with some precision companies for 30 odd years, and they've been producing like bearings. I mean, one company does the RG spindles, another company does, for example, the SG and the MG spindle. We have a company that does the bearing housings and so on. And these people are the top of where they are. They manufacture for Ministry of Defense, they manufacture for Formula One, they manufacture for surgical and medical profession, industries and so on. And their machinery at any point in time is the most suited for what we make. Companies, as I said, I've worked with for more than 30 years. So we are like a family. They understand what my requirements are, But everything is assembled, everything is checked, everything is QC'd at Vertere. Ultimately, when everything comes in, yes.
And you have some
Yes,
show us.
you were asking about the difference between the RG and the SG. For example, this is the top part of the RG platter. So that is where the mat will go, and this part is a shape that it is machined underneath. And you can see it's relatively thin. So to do this very accurately is more difficult than a thicker platter, because you have to hold it, you know. And this part, if you see, is done to be like a tuning fork. The platter, so that's where the spindle block will sit. And this part, the inside is machined the reverse of that part. And again, this is like a tuning fork, but a different frequency. You can see it's lower
different.
in frequency.
Right.
You now put the two together. They almost ring. I can lift both of them together. Can you see?
yes.
Both of them can come together. So if I now do, so the machining on the inside is extremely accurate.
Very precision.
Yeah. So if I now put the two together,
Oh.
so it's completely inert, but linearly, not non-linear, because it's basically a resistive damping effectively between the two. And although they look very similar, but it's quite a different manufacturing cost.
Can the customer can upgrade it from this model, this pattern model to this?
It is possible, but obviously, if anybody wants to do that upgrade at an early stage, you know, like after 2-3 years, we always recommend just go for the RG. If you're having your SG for 10 years and then you want to upgrade, then that's a different story. The reason I say this is because when they upgrade, they have an SG platter and a bearing spindle that it becomes redundant. You know, you can't do anything with it. So if you want to keep your SG for a while and then upgrade, then it makes sense. But otherwise, if you really want the RG, I would say wait, go for the RG, you know, from the beginning.
Right.
Yeah.
So if I want to upgrade it, I have to change the bearing also, the bearing sleeve also.
Yes. What happens is that there are two ways of doing it. Either it's done at source, or it will be done by us. You know, so it's a matter of logistics, where you are and so on, because it's very easy to for example, ship. I mean, the record player is not a 500 kilo record player. You can very easily ship it. We upgrade it, we set everything, we do all the alignment for the suspension and everything, and then send it back. When we introduced the new motor drives, the new Tempo and the Imperium are based on the big reference RG motor drive. Now, that motor drive, the generation of the signal is very different to the SG motor drive which we had originally. But because of the difference, the contact and the connector part going from a 4-point connection is gone to a 6-point connection. And therefore the motor part needs to be upgraded, the wiring needs to be upgraded. And many people with MGs or SGs or RGs, they send it they go to their retailer or distributor, they send it back to us, and within 2 to 3 weeks, 4 weeks, they generally get it back. So it's not a unusual thing to do.
So this is a
That's the Imperium.
Imperium.
Yes.
It's have a pitch control for this.
Yeah, it gives you plus and minus 0.25% and 0.75% on speed. Generally, the absolute, the exact speed of the record player is not that critical. So, for example, 33.33, whether you are 0.2%, 0.3% up or 0.2%, 0.3% down, it's not a very critical aspect, because even the cutting lathe or even sometimes the tape machine could be running slightly slow, slightly fast. So 0.2%, 0.3% is not a big deviation. But there are occasions where you may find that you need the little adjustment, either because the actual material was done at a slightly wrong speed, or you happen to prefer the pitch being slightly sharper or not. So you can adjust it, because even you look at classical music, a lot of orchestras, they tune to a different center point. So it could be 440, it could be 430 something, it could be 4. So it's not exactly that. On the RG, you have more adjustment. So it goes 0.25, 0.5, 0.75, 1, 2, and 3%. So you can actually adjust a little bit more. But with the Imperium, we did the 0.25 and 0.75, which seems to address most situations.
Go back to the technical question again. This time you design the bell to round the outer platter. Normally
Yes.
I go to the sub platter
Yeah,
one.
yeah.
What is the reason behind that?
So you're running the motor at a slightly slower speed. When I go to the outside, I can run the motor slightly higher speed. And because of that, the change between the poles becomes a little bit quicker. So it's a bit smoother running, And obviously, because you're pulling on a longer radius on the platter, for a given inertia of the platter, you need less torque than if you were on the inside.
Right. So
We can now make the bearings much better than we used to do in the past. So I can tackle that. And at the same time, I can run the motor slightly faster.
Maybe almost the last question about your tone arm. You have
Yes.
the pivot.
SG, I wanted to make a tone arm that was substantially less costly in manufacturing than the reference tone arm. It's like making a Formula One car. You can't drive a Formula One car every day. Some people may be able to have that and enjoy what it does, and quite a few people do. But it's not accessible to everyone. SG tone arm is accessible to almost everybody who is at this level of performance. So I wanted something that was mimicking what the reference tone arm did, but at a substantially reduced manufacturing cost. One of the things that is very expensive in doing tone arms is when you have multiple bearings to do. And in the past, I had done a uni-pivot that was on the NEMA in my Roxanne days. And I liked that tone arm, but it had quite a limited performance because of the uni-pivot section. And one of the reasons is that there is no such thing as a point. You say it's a point contact, but it isn't really, it's a surface. And because it's a surface, you have this sort of like a skating behavior, which has got nothing to do with the fact that the diamond is pulling the arm. Is because to do with the arm is always going up and down and is always going in and out. And one idea was a long time ago I used on the Artemis 3 ball and a fourth smaller ball going in to locate the position of the bearing. So it is behaving between a unipivot and a rigid pivot bearing effectively, but allows the arm to be adjusted for azimuth and everything very easily. So the dynamic range is increased and the noise level is reduced. And although you have 3 points, so you're slightly increasing your friction and stiction, but those points are less than 0.5 millimeter. So at 240 millimeter in front, they create almost negligible stiction for the tone arm, and the noise signature is basically non-existent because they're not moving, they're not rotating. It's only a small sliding between the 3 points. So that's how this tri-point effectively came about.
This is a quite unique design compared to other brands.
Right.
I think it's work.
Thank you.
Better the sound.
Thank you.
The material to make a plinth, is it a tune frequency or this one it's
Okay, you want a inherently non-resonant material, so you don't need to do a lot of damping, which can cause either cost if you're doing resistive damping like we do with the platter, or if you do non-linear damping with damping material, then it will cause non-linearity. So originally I went for fiber compressed wood, which was MDF.
right?
And despite all our efforts of putting piano lacquering, putting polyester coating, everything, it still was subject to temperature and humidity. And there was some inconsistency depending on where the unit was. So I was looking for something that was as inert as possible but stable, and it didn't have any sort of weaknesses against temperature, humidity, atmospheric conditions. And acrylic is one of those materials. Of course, you have to spend a little bit more money to make sure that the surfaces are polished and things like that, but it behaves totally consistently. I can take this to almost anywhere on the planet.
On the TMS3 you did some kind of material which is not the MDF, right?
No, on the 2. The TMS2, it was a resin.
On the 2,
it was a resin-based polymer.
Right.
So it's basically a powder that you mix with some resin and it's set in a mold effectively, so it gets the shape. The issue we had with that was it was too heavy for the job. And as soon as you machined it, it became slightly unstable. So it was always slight bending and even with de-stressing and so on, it was still not quite 100% stable. So with the TMS3, I went back to MDF
again.
And polyester on the outside to try and seal it as much as possible.
Right.
Yeah.
And maybe the last question, your supporting board.
Yes, basically, if you look at the RG, it's a 4 plinth design. So you've got the top plinth, which is your ground reference. Then the base plinth is actually hanging from the top plinth. The mid plinth is decoupled from the base, and then the sub plinth is decoupled from the mid plinth. So the sub plinth is sitting on the mid plinth but decoupled. The mid plinth is sitting on the base plinth but decoupled. And then the base is effectively hanging with the silicon bands that you have between the two bobbins. So there are two on the right front, two on the left front, and two on the back. And then you can adjust the height and you put another layer. But it's independent of the record player. So the record player is sitting and the shape is machined so that it's basically like a some people call it a Mitsubishi sign. It looks like a Mitsubishi sign.
It's like Mitsubishi.
Exactly. And that is because if you make it solid, obviously this part starts resonating more. So effectively, you're reducing it to its minimum structure, so that the feet are coupled through the feet to the next level.
Thank you for your time.
Thank you so much. Thank you very much. Thank you very much. Thank you for your time. Thank you.
And present your wonderful turntable.
Thank you. Very kind.
One of the best in the market.
Thank you. Thank you. Hi, I'm going to be playing an Ellis Springs track from one of our records that was half-speed mastered and cut at Abbey Road Studio by Miles Shaw, and the track is Ain't No Game.
Left to say, wake me up when it's all over. Baby, you know this ain't no game. If you could only read my mind, you would know I'll keep you safe. Wake me up when it's all over. Baby, you know it's not okay. And everything just seems so hazy. With my back against the wall, you act like nothing's going on. You lift me up and you pull me down. Baby, you know this ain't no game. Gotta wake me up when it's over. Baby, you know this ain't no game. And everything just seems so hazy. With my back against the wall, you act like nothing's going on. You lift me up and you pull me down. Baby, you know this ain't no game. Ever since you are gone, so you might as well come home. You know my days just seem so long. Ever since you are gone, you might as well come home to me. You might as well